Okay, I suppose we can go ahead and get started. It's a little bit after 12 here. So, first off, thank you for attending and welcome to the Industrial Internet of Things workshop, day one, or session one. My name's Andrew Burns. I'm a professor at the University of Northern Iowa. My area of expertise is in software engineering and embedded systems. And so, a lot of the software side of things about this setup, or I'm familiar with, but most of the lion's share of the work, the setting up the foundry, stuff like that, that's Nathaniel Bryant and Jacob Odell, also from the University of Northern Iowa. So they're kind of the main ones that have done this in their student team. So my knowledge of it is in embedded systems, software engineering, like I said, but all credit goes to Nathaniel Bryant and Jacob Odell and their student team for the work that they've done. Kind of some background about their motivations and what it is they're thinking of doing there. Obviously they're looking at Industry 4.0, which is where the idea that everything is instrumented. You're taking in readings, you're going to use that readings to make good decisions, and then repeat the process over and over. So kind of this loop, this feedback loop of taking a measurement, make a decision, make a judgment, make adjustments, and then taking another measurement, et cetera. So kind of like a closed loop process control situation is the goal for Industry 4.0, where we'd like to push everybody to be. Now, expectations versus reality, of course, are different. It'd be great to be, brand new foundry, brand new setup with, highly automated machines already with, nice, you see in this picture, a nice interface already set up. But a lot of times we're actually dealing with some older equipment, and what we have to do is augment the older equipment, or the equipment that at least isn't set up to take those measurements and make those adjustments, and kind of retrofit those with the sensors that are going to be required to do Industry 4.0. And that's kind of where this project is at, or sits, is in that, like, how do we retrofit and bring the Internet of Things to existing foundries, existing settings. Obviously, on the left-hand side, we've got what our goal is going to look like. Like, can we set up a screen like this? This is very similar to what we're going to end up making by the end of these 4 sessions. So we'll have the ability to come in and say, okay, we'll do some basic sensors. We'll do some Raspberry Pi work in setting up of Node-RED, which is the software that allows us to view this stuff, the data, and then get that screen put in there. I will mention that this was in collaboration with NCDMM, and I'll move the chat bot or chat window over so I can see that a little bit better. And so, yeah, a huge thank you for their support for the project. I should say, so getting started, our agenda, like I said, there's 4 of these workshops. Today we'll be doing the getting started with a Raspberry Pi. And then we'll move on next Wednesday to setting up a sensor and MQTT protocol, which would be like, the retrofitting of the machinery, and getting it to actually communicate, send those messages to a certain source, a central source, in our case, in the Raspberry Pi. And then July 24th, we'll go ahead and do the dashboarding and logging using the Node-RED software. Most of the software and hardware that we're using, the hardware is usually hobbyist hardware, so it's readily available and it's available for fairly cheap. And then the software we're using is all free and open source, and so you can do that for incredibly cheap as well. So keeping costs down for that retrofit. And then finally, we'll expand with some microcontroller work on our last meeting, the last day of July 31st. So yeah, I should mention, kind of administratively, by the way, if you do have any questions during the presentation, feel free to, you can either you can just speak up, or you can put the questions in the chat. I've got the chat open in the corner of my screen so I can watch that. So if anything comes up, you have a question or you need me to slow down, you need me to repeat something, just feel free to throw a message up in the chat for that. we're gonna go ahead and get started with the Raspberry Pi. Kind of today's goal, where we're hoping to be at the end of it. Able to log into your Raspberry Pi using SSH and execute commands. In order to get there, we do have a little bit more installation work to do. So in fact, that's what most of today is about, doing that installation and setting that up. But the main goal is that we end up, at the end of today or before next session, that you have a Raspberry Pi up and running, that you can connect to it over SSH, and that you can execute commands. If you can have that, then you should be able to have all of the things that we need for the entire workshop setup. I put my email address down there, and I'll repeat it at the end of this session as well. If you have any questions, you're certainly free to ask questions during this presentation. Like I said, feel free just to post something in the chat and we'll go ahead and address it. But if you'd rather not ask questions during the session, but you do have questions, or you have setup problems, you need debugging help, whatever, feel free to shoot me an email. I'm more than happy to help set you up individually, get you up where you need to go. We're just excited about the project and want to bring in as many people as possible. So, definitely anything we can do to help, get you this set up. Any questions that you have, feel free to just send me an email. I'll get back to you promptly, and we'll, get you set up, and then make sure that you're up and ready to go by the next session. So the supplies needed. So you've gotten the supply list. Just for kind of repeating, like a laptop computer to be using to connect your Raspberry, or connect over SSH. We asked for a Raspberry Pi Zero. I actually have a list of these if you want to, or have them here if you want to see them. But a Raspberry Pi Zero, which is a low-cost single board computer, and we'll use that as like our host for our data. A micro SD card, 32 gigs or larger, the reader, the charge cable, and then a couple of adapters to be able to use the Raspberry Pi Zero. Because it is small form factor, it does have, like, instead of a full HDMI output, it's micro or mini HDMI. It doesn't have a normal USB size output because it's meant to be a small form factor. I will say that once we get the setup complete, that once you can SSH into your Raspberry Pi, we no longer will need to connect to it with the USB or connect to it with a monitor through the HDMI port. So that is kind of nice. We need a temporary access to the system directly with like an HDMI port connected to the monitor, but that will drop out at the end. So we won't have to do that for very much longer once we get through today's session. So the first thing we're going to do then with our Raspberry Pis, we're going to want to do is to go ahead and install an operating system on them. Raspberry Pi, the foundation does, besides designing the hardware, also offers an operating system specifically made for the Raspberry Pi. There's a couple of different ways that you can install it. We've found the easiest way to install it has been to go to raspberrypi.com/software. From there, you can go ahead and download the Raspberry Pi Imager, which is available for many major operating systems, Mac, Windows, and Linux if you're running that. There's other ways. You might have bought your Pi Zero already with a wire or with an SD card with the operating system already set up. If that's the case, you can just use it that way. That's absolutely fine. Otherwise, you can download the Imager for your operating system. When you go to run the Imager, you'll choose, and so you'll choose the OS from it. We're going to recommend the 32-bit legacy port, as the Raspberry Pi Zero is a lower cost single board computer than the Raspberry Pi. I think they're up to version 5 now. So we're going to use the 32-bit legacy version for that. You'll choose your storage. This is if you take your micro SD card, insert it into your SD card reader, connect that to your computer. it should be the only thing that pops up on there. So it should be impossible to ruin your existing hard drive. You plug in your USB and it'll pop up and say, yes, that's what it needs to have. And so select your USB. Then we're going to go into the settings. Now this screen might look a little different on yours than it does on mine. I'm running Linux at the moment, but what you can do is we want to check enable SSH, check that box. SSH just stands for secure shell. It's a way for us to communicate with the Raspberry Pi remotely. So instead of having to be connected to the HDMI port and have a keyboard plugged into the Pi, we can use our laptops or our desktops and basically use remote access to get to it using SSH. So you want to make sure that that's enabled, and password authentication for our purposes is fine. If this is something that you're going to be using more, like this setup will work just fine for the workshop. If this is something though that you're going to leave running longer term, that you want to step up to something a little bit closer to like a production ready environment, I'd suggest not using password authentication. Feel free, if you get to that point after the workshop, shoot me an email. I'm happy to help you get that set up if that needs to happen. Scrolling fast. The other thing it's going to ask us for is the username and password. We're going to select Pi as the username, and our password, I just typed in workshop, all lowercase. You can set that password to anything that you want. Again, workshop is a pretty weak password, which it will work for now because we're just setting this up to do the workshop. If you intend to, again, use this long term, I'd suggest something a little bit harder to guess for your password. Then we're going to configure the wireless LAN. We're going to check that. You should have an open Wi-Fi network for you. Open doesn't necessarily mean that it has no password. You can obviously enter the password at this point, but open as in like you can add devices to it. You can join the network and send and receive data on it so that you can say SSH into it later. So you'll put in whatever your SSID is of the Wi-Fi you want to connect to. You'll put in the password of your Wi-Fi, and then the wireless LAN country. It should connect no matter what, but go ahead and select for us US. If I can slowly scroll here. There we go. A lot of the settings on the Raspberry Pi are actually set for Great Britain. The Raspberry Pi Foundation is a British company, and so that's why like a lot of the defaults will be not like what we're used to for US standardization. You can go ahead and set locale settings if you wanted to, picking America, Chicago, whatever your time zone is in a US keyboard. These buttons, you're fine to just leave exactly as they're given. You don't have to change anything on there. And again, if you're curious about what they do, you can certainly contact me and we can discuss it. So you've set up those options. When you're ready to go, you can go ahead and press right. And what that's going to do is then take a bootable image. That is an image that I can just put on plug into the Raspberry Pi and it'll start up and get it going. So when you're done with that, just press right and it should pop up. And this is contained in the slides as well. So we'll send copies of those out. So I didn't want anybody to miss anything. There's the OS, the storage. There's the settings shown on the right-hand side there. And then we write it and eject it from our computer. Are there any questions so far about getting that set up? Okay. Again, if you do have questions as we're going along, feel free to interject here, and we'll take care of them. All right, so we've got our Raspberry Pi operating system written onto the SD card. We're going to go ahead and insert the SD card into our Pi 0, which you can see in the picture. Number one, it's the small little port at the bottom there. Then we're going to connect an HDMI to mini HDMI converter, again, which is in your materials list. And that's going to allow us to connect our HDMI or our Raspberry Pi 0 video output to a monitor with an HDMI port. So you can hook that up there. TV, like it would work on a TV as well. Just the refresh rates are different, but it would work just fine there. If you're in like a conference room and you have a projector with HDMI input, that would work through. Just something that lets you connect and see the output, the video output of the board. Then you're going to go ahead and connect the micro USB to USB converter, and then you're going to connect a USB dongle for wireless mouse and keyboard. If you don't have a wireless mouse and keyboard, that's okay. I'll show you when we walk through how you get the IP address. I'll show you how to do it using just a keyboard, so that if you, again, don't have a combo like that, you can still do the project. So once you've got that ready to go, you go ahead and plug in the micro USB cable into the power in port, the one at the way it's oriented this way, quote unquote, at the top, and that should go ahead and start up for you. We do mention the note, make sure it's the last thing that you connect. That's just so that it doesn't, like while it's booting, not recognize that there's a keyboard connected. So now we'll connect the keyboard and then boot, and then it's guaranteed that it's going to go ahead and find that and get us going. Okay. So when you plug it in, it's going to show something that's going to look a little bit like this. You don't have to press any buttons or anything. The default options that it's going to boot with are going to be fine. And it'll take you to a screen that looks something like this. Okay. What we can do is we want to open the terminal, which is the number 7 here in the diagram, this little symbol up in the taskbar. If you have a mouse, obviously you can just take the mouse and go and click on it. If you don't have the mouse, you can press Control, Alt, and T all at the same time, T for terminal. And so I'll show that here. Control, Alt, T, and then it pops up the terminal for you. So if you don't have a wireless mouse keyboard combo, that's okay. The only thing we're going to do here is get the IP address of our Raspberry Pi so that we can connect to it with our other device. So again, we're just gonna, you're gonna use the HDMI port and that mini USB the minimum amount possible just to get our information so that we can see. So what we're gonna do to get the information that we need is we're gonna type in ifconfig, that is ifconfig, and then press enter on the keyboard. And what that's going to do is give us it stands for interface configuration, and it's going to give us information about the network interfaces for this particular Pi, including the wireless connection that we have with the hotspot or with your access point that's going to allow us to go ahead and SSH into it. So we run that. You'll notice it'll say the LO one. You can not, skip over that one. If you've connected over wireless, it'll say WLAN 0. What you're looking for is the number on the second line that says INET, and then there'll be 4 numbers separated with periods. That's going to be the IP address of your Raspberry Pi. And so just make a note of that because we're going to use it later. So again, if I type it on mine, this one's not connected over wireless because it's a virtual machine, but you'll notice there's LO, skip that. There's something else, probably WLAN 0 for you. And you're looking for this thing, iNet, and then the four numbers that come after that. Okay. Yeah, any questions, comments, concerns? I'm kind of moving quick here. The intent is that you can follow along during the workshop and ask questions. So we've planned some pauses in here for questions and for letting people keep up. So if you do have anything, just let us know. We're happy to go ahead and interject there or talk there. So we can go ahead and keep going then. The last thing that we're going to do today is going to be connecting with your Pi over SSH so that we can go ahead and disconnect the keyboard and mouse. We can disconnect the monitor. And then the only thing we need to have in there is the SD card with the operating system and the power cord. Once we have the ability to connect to it over SSH, that's going to make our changes and work with it pretty easy. What you'll want to do is go to a terminal or a command prompt. If you're in Windows, you can go to the Windows menu, and there's probably command prompt as one of the options. If you have a Mac, you'll be looking for the terminal application. If you have Linux, you're going to run and open up a terminal or a shell and type in SSH space Pi or whatever the username that you chose was. Again, for us, it was Pi. At the at symbol, and then that 4 number, the dotted octet that it has, in this case 10.28.196.103. Mine would be 10.0.2.15. Most likely yours is going to be 10 dot something or a 192.168 dot something. So you'll type that in and then press enter. What that's going to do is attempt to, again, connect through secure shell. So create a secure connection remotely to your Raspberry Pi Zero. When you do that, it's going to ask you bring up this message about the authenticity of the host can't be established. That should only be displayed the first time you connect to it. It's basically saying, hey, the machine you're about to connect to, you've never seen before. So I can't verify that it's a trusted machine. You should only have to say this once. So when it comes up, you'll go ahead and say yes. If, however, it comes up more than once, there could be a network config issue or something. Again, reach out, let me know if that's going to be a problem for it. So you'll type in yes and hit enter, and then it's going to go ahead and add that list to known hosts. There's 2 things that might happen at this point. Number one, it might just close the connection. So if you have a Windows machine, that's probably what it's going to do. Or it's going to ask you for the password for the user Pi. If it does close the connection and takes you back to the command prompt, you'll re-enter the command SSH Pi at IP address. If you don't want to type the whole thing again, you can just press the up arrow, and that will go through your previous terminal commands. So you can up arrow until you get to the SSH Pi at 10.128 or whatever your address is. In this case, it's the most recent one. Excuse me, that's on there. Now it's going to ask, notice it's asking for the password. You'll type in our case, workshop. In your case, maybe you set that password to something different. The important thing to note is that while you're typing here, nothing's going to be displayed. So it's not going to show you like asterisks like you would on a web form when you type in the password. It does that to prevent leaking any information about your password. So if somebody were watching you, they couldn't just look at the screen and say, oh, you have a 10-digit or 10-character password. So it's not going to display anything. It is taking input, however. So let it pop up, ask for the password, type the password in, and press enter. And when you do that, if you've got the successful password, it should go ahead and show you a screen that's like this. You'll notice down here at the bottom, this is telling me I'm user Pi on the machine or the host Raspberry Pi. So that's it telling me like I have successfully remotely connected to the Raspberry Pi. And now I can execute remote commands. Any questions, or do you want me to pause a little bit and let everybody catch up, or? Okay, we can keep going again if speak up if you do have questions or you need me to slow down. We'll actually have in the presentation I was planning on having some time to let people follow along. So we will have some extra time at the end, but what we can do there is just explore a few more things about this Raspberry Pi and the Linux operating system that's going to help us when we go to retrofit and connect some of those other sensors. All right, so we've installed Raspberry Pi OS. We are now connected over Secure Shell or SSH. We are now connected to the Raspberry Pi remotely. Again, at this point, you can remove the HDMI plugin and the USB plugin that ran the keyboard and mouse for you. Leave in, obviously, the power plugin to keep the Pi running. One thing we're going to do is we're going to try to configure some of the communication protocols that are being used. A lot of one of the really common protocols for the sensors that we have, or for sensors in general, and for the sensor that one of the sensors we have is called I2C, inter-integrated communication, I believe is what it stands for. So what we're going to do is configure that on the Raspberry Pi Zero so that we can go ahead and read from our sensors using that interface, get the data and then send it on or display it so that you can make good decisions with it. What we're going to do is type in sudo space rspi-config or rasbi-config, and then hit enter into our terminal. If that works like expected, number one, it's probably going to ask you to enter your password again. Again, same comment as before. Just because it doesn't display anything doesn't mean that it's not actually working. So I'll do my sudo rasbi-config in my window here. I guess that one didn't prompt me for it, but it should take me to a screen that looks a little bit like this. Rasbi-config is obviously just a configuration utility for the Raspberry Pi. What we're going to do is we're going to enable one of the interfaces. So you'll go ahead and scroll down. You'll first select interface options, and then scroll down to I2C. And then it's going to ask, would you like the ARM I2C interface to be enabled? And you can go ahead and select yes. So again, interface options. And then on your, this one is, since it's a virtual machine, doesn't actually have the special hardware. So I can't show you that step, but the screen will look exactly like this and lets you connect to it. You'll notice there's some other interface things in there that might be familiar to you if you've done some embedded programming. So for instance, the remote GPIO pins, one wire, serial port SPI. So those, I4 through I8 are common protocols that are going to be used for embedded devices and reading from and writing to sensors. Again, the one that we care about right now is the I2C one. We'll leave the rest of them disabled until we need them, and then we can go ahead and connect to them. Once you've done that, it'll take you back to the main screen, and then go ahead and press tab twice. And it should take you to the finish, and then just press enter, and then your changes will have been saved. And that should be all that you need to do to enable your I2C and have you connected and ready to go. So, questions for me? Hopefully, these were the three major steps that we went through. We'll move on to some additional information, but I want to make sure that everybody's clear with the three major things that we did. Number one, installing the Raspberry Pi OS. That's not, if yours came installed, that's fine. That we had to do because it was a necessity to let us use the Pi. The big things I want us to do that we're going to start doing next week is going to be connecting over SSH and executing basic commands. So if you have any questions in particular about how can you connect over SSH and execute those basic commands, I'd encourage you to reach out, send me an email, and I'll get back to you as soon as I can so that we can catch you up to speed and get you where you need to be so that you can execute other commands. Let me zoom this in a little bit, and then we can show a few more. Sorry. Guess it doesn't want to allow me to do that. That's nice. We'll show a few more commands that are going to come in handy for us that we're going to need. Number one, the sudo, you notice that I said sudo rasb config. Next week, we'll see something that's like sudo apt update, for instance. The sudo command, it just means switch user and then do the operation as a different user. So basically, run this as somebody else. If you don't supply any arguments to sudo, then it defaults to running it as the administrator or the root account. And so anytime we're making changes to the entire operating system, like changing the enabling I2C or installing more software, anytime we have those kinds of things, we'll have to run sudo with it because we'll need to be prove that we have root, that we have the permissions to be making those changes. The command, and you can follow along and run this on your Pi right now, sudo apt update. Apt is a package management tool for the Raspberry Pi Linux operating system. It's going to be necessary, so we're going to install some drivers for some of the sensors. So we'll use apt to go ahead and install those drivers. What update will do is actually, it doesn't install anything, it just gets me an updated list of what could be installed. So I'm going to run it, and you should see the same output on your SSH connection. It's going to look through those lists and say, okay, now I have the full list of software that can be executed. Software that can be automatically installed. All of this stuff is completely free and open source. So it's kind of cool. We have an accelerometer sensor. Somebody has already written a driver for that, and basically donated that software so that we can run it for free and use it for free without any major restrictions on it. And so that's one of the nice things about using Linux and the Pi system. It's why a lot of IoT systems, especially like the ones like this, can be done for so cheaply. So we have sudo, and then I mentioned what apt does, which is the package manager. Apt update gets you the new list of software. Obviously, apt install is going to install new software for us. And then if you start typing a command and press tab, it will auto-complete that command. And so here I just did pf to see a list of software that starts with the letters pf, hoping that it would be a small list, and it was. So then if I wanted to install pforth, I would sudo apt install pforth and then press enter, and then it would go ahead and automatically download and install that for me, and then it's done, and then I can go ahead and use the software. So that's huge for our ability to build the system up. We're going to show similar things when we go to install Node-RED or run our accelerometer sensors. The other tool that we'll use, so apt is a package manager for the Linux operating system. So when I install things through apt, it's available like as standalone program on my Raspberry Pi Zero. We also will write some Python code to interact with our sensors and send the data. When we do that, we'll actually install Python packages that are meant for these device drivers. So to install things for Python, we actually use pip, which is the package interface for Python. Sorry, drawing a blank on the one, but it's the package manager for Python. So we'll say pip, and then we'll give it the name of something we want it to install. Sorry, pip install. I'm trying to think of a popular Python package. You don't have to install Flask, but it's one that I am aware that's out there. Yeah, and then it'll go ahead and looks like you don't have to install because it's already installed on this one. Did not know, but that'll go ahead and install the Python package for you that you want to get set up for whatever the device drivers that we have are. So we have the ability to connect it. We know some basic remote commands. Any questions? Again, like the goal that we'd have at this point would be that you can that when I say SSH into your Pi and execute this command, that you can do that. That's where we'd like to be after this workshop. So if you have any questions to get to that point, feel free. You can ask them now, or you can again send me an email. Okay. We'll just do then a few Linux commands that's going to help in next Wednesday's presentation to get things set up and moving. I will update the slides with the additional information that we're kind of covering here. One thing you might find handy is the clear command. What that's going to do is just clear the terminal. So like, a lot of times if I install something and I run a couple commands and I don't want to look at that messy screen, I'll just type in clear and it pushes the old information out so that that's the only thing on my screen. When you first SSH in, you'll be, basically you're in the machine in a particular directory. If I do ls, that will list the contents of that directory. And yours should have something that looks very similar to this, if not exactly like this. These are the default folders that are built by the operating system when it installs and adds you as a user. So ls shows me these are the directories that you're in. I can do pwd, which will show me what directory I'm currently in, my present working directory, or print working directory. So I'm in home/pi. Again, every time you SSH in, it's going to take you to that same spot every time. So we're going to be creating Python files and maybe making some notes in files. You don't have to remember the full, what's called the path to those, as long as you keep them in that initial spot when you first go into SSH. So that's where it's going to go ahead and use your information. If you need to switch folders for some reason, say, you went through the web interface, you went through the HDMI interface and downloaded something. Well, that's going to be put into the downloads directory on your Pi. CD will change the directory for you. So CD for change directory. And then you can simply enter in the name of the folder that you want to enter into. You'll see that the things represented in blue there are my folders. And then you'll also notice that I use the tab to autocomplete that command. Then you'll notice that it's updated, telling me, hey, you're in, the tilde stands for your home directory, that spot that you automatically go to when you SSH in. So, hey, you're at the default spot, and then from there you went into the downloads folder. And so now I am now by print working directory. Now I'm in home Pi downloads. And then if I ls list the contents of that directory, if there was something there, it would let me know. To go up one directory, you can do to go back to that default starting place that we get when SSH. I can type in just cd change directory, but not tell it what directory to change to. By default, that takes me back to that home directory, that default entry point to my computer. I could also do a cd and then a tilde, meaning this is the shortcut to your home directory. And then I could also do a cd and then type in the full thing, home/pi. All of those take me to the same place. So cd with no parameters, cd with a tilde, or cd with the full working path gets you back to that starting point. When we make our Python files, we will just store them in this default directory, so you don't have to worry about managing your folders. However, you probably will want to move them into folders if you're maturing your system a little bit. If you want to make a folder, you can do mkdir, which is short for make directory. And so directory folder synonyms there. So I can say make directory IoT scripts. And then if I do an ls now, you'll see that IoT scripts is now a folder inside of my Raspberry Pi. I can cd to IoT scripts. And then from there, I can go ahead and execute the rest of the commands that we're going to start doing on Wednesday to actually set up our files. Looks like it's about 12:50. Any questions for me? Or anything you'd like me to go over again? New material you want to see before next Wednesday? Okay. I can keep going for a couple more minutes at least. And I don't want to keep you late or anything, but we've got definitely a lot to talk about, and so we can keep adding some more skills and stuff. I guess one thing we could do is I can go through as well the as maybe a precursor to Wednesday, some of the devices we're going to be working with, and were on your materials list. So we've got, I think probably where we're going to start on Wednesday. Next Wednesday. You can tell I've got the teacher thing of like assuming that today's Monday and we'll talk on Wednesday. But no, when we talk next Wednesday, we'll be using the accelerometer. I don't know if you can kind of see it. It's got the information printed on the back of it as well. The ADXL 345 will be the one that we're going to be using. It's going to be, why choose the accelerometer? It measures something that we can change, or we can operate on our environment and see the change. So I can take the accelerometer and flip it upside down, and I would expect the values to reverse, because there's always going to be that gravity acceleration on your thing. So you can tell roughly an orientation from the accelerometer. At least you can tell when something has switched over. So we'll connect this to our Raspberry Pi. We'll connect make a program to take the output of this device and send it out to the network. In particular, send it out with the Node-RED setup, and then we'll show how Node-RED can make a dashboard that lets us see, and then we'll flip the accelerometer over, and you'll be able to see the updates happen in real time with our Node-RED setup. So that'll be pretty neat. I think that's the major sensor that we have. We've got some breadboard supplies too. Again, when it comes time to actually use those, we'll make sure to walk through slowly. The intent is, certainly if you're watching this on a recording, that you can follow along with the recording. We'll try to pace it so that you can try to keep up. The intent would be that you keep up with us in real time, and then if you have questions, you can go ahead and ask them. I can promise you, if you have a question on something, everybody has a question on something. And so, it doesn't hurt to go ahead and interject and let me know that, so I don't fly by. Yeah. So, I guess some concluding thoughts. Today we got started with our Raspberry Pis. The next step is again going to be setting up that accelerometer and the MQTT. Which is a protocol used frequently for Internet of Things devices. So we're going to set that up to send that information out. And the nice thing is, MQTT is like a standardized format and protocol that, hey, once we've got this sensor, which maybe, our sensor accelerometer, but maybe the sensor that we're going to be plugging in, or that you're plugging in at your site, could be a thermometer. It could be humidity, it could be pressure, it could be, a number of things, and they could be made by, a number of manufacturers. So there's definitely, as you might have noticed when you're shopping for the supplies here, there's a lot of different sensors out there, and even of the same sensor, there's a lot of different options on what you get. The MQTT part of things is going to standardize that for us, and make it so that we don't have to worry about this one's data comes in, in big endian, and this one is in little endian, or something like that. It's going to give us a standardized format so that Node-RED can consume it regardless of the make and model of the accelerometer that we have. So yeah, we'll get that set up on July 17th. And then again, finish off with the Node-RED and expanded microcontrollers. But the next thing to look forward to, I think, is getting the sensor up and running and sending its data out to the network. Otherwise, any other questions? Or Sherry, can you think of anything else you want me to add? Or I know we've got just a couple minutes left, so.
I think we're good. I think we're good. Thanks.
Okay. I think I included, yeah. Yeah, I'll just stress again, questions, concerns, you need help getting that set up, getting these 3 steps done before next Wednesday. Reach out, shoot me an email, happy to help, bring you up to speed so that we can go ahead and play with those sensors next week. Okay.